We've gone over a first round of studies into machine learning, and now we're going to do our second round, which includes not just one concept map per student, but two concept maps per student, and also a journal entry. And so these are the three topics that we're going to be going over. The first one is decision trees, the second is random forest trees, and the third is linear regression. And these are three different strategies and three different algorithms that's used to solve different types of data sets. And so ideally I'd like you to go over all of them, each go over all of them, but only put together a concept map for one topic, right? But if you don't have enough time, which I don't think you will, you just want to go ahead and dive into one. And I'm going to let the grouping happen by itself, right? So you find out who you want to pair with and then decide on which topic you want to go over. And so for decision trees, I found this really cool blog by David Fumo called Intro to Machine Learning that's really hard to find. So you need to type in basically this exact same text here, and that will get you to this link. But then, and so this is like the first reading that you would want to do. And then from there, I think at the bottom, there's a link. Yeah, there's a link here. The bottom is next is the data iris set, which will take you to here. And if you can't find this one, then you could just type this in exactly, but put a number 2, and a link to this one here will show up. And then you can go ahead and read through this one as well. And then there's code that takes you through how to implement a decision tree using NumPy and I think it's scikit-learn. And so you would want to go through that, and then next you want to go to the next one and then explore Panda's library. And here you're going to use I think this is a decision tree as well. Let's see, scikit-learn. Predict cloth file scoring. Yeah, this is going to be using a decision tree as well. And so you can go ahead and go through this, and my suggestion would be to add one line of code, and very often he doesn't print out what is loaded in. Like for instance here, there's 2 lines of code. Okay, you drop it into PyCharm and then print out iris, see what it is, right? Then go ahead and drop in this line of code, print out features, what is it? Then you'll take a look at the data instance field of iris and put it into X, and then print that out and see what it does, right? Sometimes he has it explicitly, but a lot of times he doesn't. And when I was going through this, I was printing everything out and just kind of wrapping my head around how NumPy functions and how we can manipulate data using this framework here. And so that's what I would have you do to go through decision trees. And by the end of that, you should kind of feel like a data scientist, because you will have implemented your first algorithm using a very popular data set. Okay, and so that's a pretty good feeling to have. And then the next one is a random forest tree, which is a branch off of decision trees. And the way that I want you to go through that, if you're going to go through that, would be, of course, to go onto go onto YouTube, look at any intro videos that you need in order to get an idea of how that exactly works. And in order to understand random forest trees, you kind of have to have your head wrapped around what a decision tree is, because this is just an explosion of decision trees, and then you take the average or the majority rules. So the decision tree with the most that point to one answer being true, the most of them that are pointing to one answer being true, that is the correct answer, right? Or not the correct answer, but that's what this algorithm is going to be determining. And for a lot of problem sets, it is the best way to attack or predict a piece of data from the data set. So you kind of got to have the backtrack and find out what decision trees are, and then you can get into random forest trees. And this tutorial here is pretty good. I went through this one. I believe it's this one. And so same deal. Just go ahead and drop in these lines of code one at a time. If you're a little unsure of what's happening after doing some research, just print out df and see what is this function read SCF read CSV doing, and what's up with this clean? We'll just break it down, line at a time, just print things out and see what's happening. And you might want to go through this one as well, a YouTube video going through this tutorial, this explanation, where he used a random forest tree in order to analyze the Titanic data set, which is a list of the passengers and their various characteristics and who survived and who died. And you are going to create an algorithm that predicts whether a character, a person on the ship, should survive or should die, or not should, but will end up surviving or will end up dying. And that takes into account different things like their class, how much they paid for their ticket, where they disembarked from, their age, sex, all of those things, right? And then the last set is linear regression. And so that one, I would want you to go through this video. This guy, he's pretty cool. Just go ahead and type this into YouTube, and you can go ahead and watch this. This is part 1 of linear regression, and this was a algorithm that was gone over earlier in the introductory video, and now we are revisiting it. And then there's a part 1 and a part 2 as well, right? And then part of linear regression, part of the algorithm requires you to have an understanding of gradient descent, because they use this strategy in order to minimize an error, right? It's part of the algorithm. And so gradient descent is gone over. That's how I originally got to this guy's videos, is through his video on gradient descent. But now I can't seem to find it. I believe this one's it right here. Yeah, this one here. Right, and so this is his explanation, his mathematical explanation of gradient descent. And you guys, I feel, are a lot more hip to calculus and how it works and the explanations and the visualizations. For me, I've been super dusty on this whole topic, and so I've had to go through a lot of review to kind of wrap my head around, what is a derivative, and what does it actually mean, partial derivative, and how can we use it in different applications, things like that. And if you are kind of like me, where it's not as clear cut, or maybe you haven't taken calculus yet, I found in my search for answers, I found this guy's channel, 3 blue 1 brown, which is like a reference to his eye color. I'm not sure what's the deal behind that, but this guy uses some kind of a library, that's a Python library that allows you to create visual graphics that are, just extremely well made, right? And so he goes through the essence of calculus, and watching this, I feel like even if you do have a firm grasp of calculus, it will be, an enlightening experience, or one where you can have a very clear understanding of different concepts in calculus, and what they mean and how they mean it, and what diagrams to draw, and all these different nuances of calculus. And so it's very different from a video that something like this, where it's just teaching you the steps 1 2 3 4 5, and you'll get the answer, right? And this is how I was taught math throughout high school, junior high, elementary school, all the way through college. This is the way I was taught, right? Without any application, without any further explanation. The way that this guy does it starts with a I don't even know how to explain it, but he runs through it as if you are solving the problem of the problem that calculus solved yourself, right? So he takes you through those steps conceptually. Anyways, 3 blue 1 brown, awesome. So you would want to watch that in order to get hip, get sharpened up on partial derivatives, because it's applied over here, right? And that would be what I would recommend for you if you're doing linear regression. And and he also goes through the code on how to program an algorithm. And then from here, you can go ahead and go onto Google and find a tutorial that implements linear regression, so that you can import a data set and then run linear regression on it and see if you come up with a good model for predicting a certain label in the data set. So that's about it.